Assalamu alaikum students. Today our topic is properties of alkene and this lesson is aligning perfectly with the 10th grade chemistry syllabus. First of all see the content of lesson. In the contents we have introduction, then physical properties of alkene, chemical properties of the alkenes, halogenation and reaction with KMNO4. See the introduction. Alkenes, as you know, are the unsaturated hydrocarbons. Alkenes are hydrocarbon having carbon-carbon double bond, and this double bond make them very reactive. Even this double bond make them more reactive than alkanes. See the physical properties of alkenes. Unbranched alkene containing 2 to 4 carbon atoms, that is ethene, propene, butene, are gases at room temperature, and those containing 5 to 8 carbon skeletons are liquid, while those containing more than 18 are solids. They are insoluble in water but soluble in organic solvents such as ether, alcohols, and carbon tetrachloride. They are lighter than water, has limited density than even less than zero point 0.8. Melting and boiling point of alkene increases with increasing the molecular weight. Further, branched alkene have lower melting point than straight chain alkenes. Alkene have higher melting point than alkane with the same carbon skeleton due to dipole-dipole attraction, and this dipole-dipole attraction is due to presence of pi bond double bond. See the chemical properties of alkene. First chemical property which we will discuss here is halogenation of alkene. Halogenation means addition of halogen such as bromine, chlorine and iodine. The molecule forms are saturated with carbon-carbon double bond, each becoming bonded to halogen atom. For example, look at the structure of ethene plus bromine. Here they are react together to form dibromoethane. There are two bromine atoms, so it is called as dibromoethane. This reaction is same for chlorine and iodine, except we are only changing the halogen atom, and this reaction is used to identify the saturated and unsaturated hydrocarbon. When we are adding orange brown, reddish brown or even orange brown bromine water to a saturated compound such as alkane, no reaction will happen, it will stay bright orange or reddish brown. But if we add it to an alkene, the bromine will add across the double bond, making a colorless dibromo compound, so bromine water is decolorized in alkene. Then come to the second reaction given in 10th class syllabus, that is oxidation reaction of alkene, and this can be done with the presence of KMNO4. Potassium permanganate is an oxidizing agent. It gives oxygen in neutral as well as in alkaline medium. That oxygen obtained is oxidized the alkene into 1,2-diol. When ethene or ethylene react with alkaline potassium permanganate, it gives 1,2-diol ethane, or we can say that ethylene glycol. Hydroxyl group across the double bond is thus known as the hydroxylation reaction. Since during this reaction the pink color of potassium permanganate is discharged and brown color precipitate of manganese dioxide is obtained, and this reaction is used as a test for unsaturation under the name of Bayer's test. See the reaction. We have two molecules of ethene react with two molecules of KMNO4, and two water molecules are also added, and resultantly we are getting ethylene glycol, two molecules of manganese dioxide and two molecules of potassium hydroxide. This is the mechanism of reaction. Look at the mechanism where we are having ethene, it will convert it into 1,2-ethane diol, or we can say that ethylene glycol. Then we are also having the same reaction with propene and we are getting 1,2-propane diol, and this reaction is known as the Bayer test. Thank you.